Hello everybody and welcome to example 2. We are looking at page 61 in the workbook here. In this video we're going to look at part A of this, so let's read this together. They'd like us to decide which of the following linear transformations T are invertible and to give a reason. Okay, so in part A they're describing a function T that goes from R2 to R2 defined by T of A1 and A2 is the ordered pair A1 plus A2 and 0. Okay, well, what do you think? Is this an invertible function or not? Okay, well, I claim that it's not invertible. Okay, why might that be? Well, remember that to be invertible, the function needs to be both one-to-one and onto, and I claim that this is not invertible because it's not onto. Okay, so let's think about what that means, not onto. Okay, so that has to do with whether or not we can hit everything that's in our codomain. So I claim that the way this function is defined, it's not possible to get every vector in R2 as an output. And the key to maybe seeing that is to notice that the way this function is defined, the second coordinate is always 0. So for example, we can't hit any ordered pair that has a 1 in the second coordinate. Okay, so our justification for this claim that we made is to just make the observation that, I'm going to go to the next line, 0, 1, for example, is not in the range. Okay, because if the second coordinate is 1, that doesn't fit with the way our function is defined. Okay, now that's not the only reason that this is not invertible. Okay, that certainly suffices. We have answered the question completely, but I'd like to give you another reason, just so that you can see that with a lot of these problems, there's not just one way to explain it. Okay, so another observation that we can make here is that if you take the ordered pair negative 1, 1 and substitute it into our function, okay, here's our formula again, we're actually going to get 0, 0 out of that. Okay, because negative 1 plus 1 is 0. And so what that calculation tells us is that the ordered pair negative 1, 1 is in the null space of our linear transformation because we substituted it in and we got 0 out. Okay, but what we've discovered then is that negative 1, 1 is a non-zero vector that's in the null space. Okay, so we've really shown then, I'm going to run out of space here, so let me go to the next line. So the null space of T is not just the 0 vector. Okay, negative 1, 1 is a non-zero vector that's in the null space. Does this remind you of a theorem that we talked about earlier? That sounds an awful lot like theorem 2.4. That null space not being 0 tells us that T is not one-to-one. Okay, by theorem 2.4. Okay, and if it's not one-to-one, it's not invertible. Okay, so you can take your pick. Either of the two reasons that we gave are justifications that this function T that they gave us is not invertible. You can maybe think about it, and I bet you can find other reasons.